Hello, all you algebra students out there. I'm here to work this problem with you. The problem you see here actually looks like a problem I've seen in a science class before, but we're not here to talk about science. We're here to talk about how to just find t. Now, one thing I want you to recall is that we know we're not going to get a numerical answer for an actual numerical quantity for t, and I know that because I've only got one equation here, and there's three variables. And we know that if we were actually going to find an answer for t, a numerical answer, that the number of equations must match the number of unknown variables. So because we don't have three equations here, we don't have enough information to actually get a numerical value for t. However, we can manipulate this equation to isolate the t and actually find out what t would be equal to. So you'll notice that I have a little thought bubble here. What's in the thought bubble are my restrictions, and either your teacher will talk to you in a future lesson about how to find the restrictions of an equation like this, or I will prelude to the fact that that will be coming up, or jog your memory that it's already happened. But regardless, there's restrictions to this equation. We don't want there to be imaginary numbers, and we also don't like to have the denominator equal to 0. Because of that, we now have restrictions on u and t that will allow us to have real numbers and define solutions. Your teacher will talk to you a little bit more about that later. Let's jump right in and actually solve t now. In order to get the t isolated, I'd first multiply both sides by what's in the denominator. Both sides of my problem. On the right side, it will cancel, leaving me with just the square root of t. And on the left side, I will just be left with the multiplication of v times the square root of u. It doesn't matter which order because multiplication is commutative. The next thing I'm going to do is I will want to get rid of that square root symbol that we see here by squaring both sides of my problem. When I do that, I'll get rid of the square root and be left with t. And on the left side of the problem, I will be left with v squared. And then, of course, the square and the square root will cancel with the u. So my final answer to get t isolated is v squared u. But don't forget, we had those restrictions. So we have to include that as part of our solution, t equals v squared u, such that our restrictions were t has to be greater than or equal to 0, and u also has to be greater than 0, so that we have real, non-imaginary, defined solutions.